Recall matrix. We talk about this. Matrix is a rectangular array of numbers. It contains vectors, right? Where vectors can be rows or columns, right? Row we denote m rows, and column is n columns. Then your matrix has a dimension of m by n. The entry is aij, where I is the location of the row column, and j is the location of the, I is the location of the row, and j is the location of the column entry. Now, I never talk about square matrix. It's a very important matrix. It's allowed to use more matrix operation as opposed to rectangular matrix. Right? We see why when you multiply two matrices. So square matrix means the dimension of the dimension is going to be m by m or n by n, right? That means same number of rows and same number of columns. Hence square, right? Same length, same width. So for example, is this a square matrix? Yes, right? It have the same number of rows, the same number of columns, 3 by 3. So this is 3 by 3, so yes. Can you find me the entry A32? Very good, 9, right? Not 12, right? Rows come first. So third row, second column, so 9. Is we okay with this? Yeah. This slide is very easy, I promise. Another matrix is row matrix, or in linear algebra, they call that vector matrix. Row matrix is just one skinny line, horizontal line. So it have n columns, but only one row. So for example, like this one. So that is row matrix, right? Just one long row. You have how many columns here? 1, 2, 3, 4, 5 columns, but only one row. It's the. Can someone tell me what the dimension of this one? Yeah, 1 by 5. And column matrix, you know it, skinny one, right? So column matrix is opposite to row matrix. It should have what? One column, but m rows. So for example, 5, 2, -5, 0, something like that. This one has the dimension of what? 1, 2, 3, 4. 4 rows, so 4 by 1. That's the column matrix. Transpose matrix. I like this one. It's an important one. Maybe we don't use this a lot in this class, but for linear algebra, it's important. Right? If given matrix A's have a dimension of m by n, then if I want to find the transpose will have a dimension of n by n. That means rows become columns, columns become rows. So let me give you an example. 3, 2, 1, -5, so make up some number, 10, 0. So that's matrix A. If I want to find row A transpose, denote A capital T, and please do capital T, don't do little t. That means differently. Can someone tell me what's A transpose? 3 by 2. Yeah, 2 by 3. So what does 2 by 3 look like? That's second row or first row? Oh. Right. So first column becomes first row, right? So this column becomes the first row, and this column becomes the second row. That's it. So 3, 2, 1, and then -5, 10, 0. I don't have to make it too skinnier. That's it. That's it. Does anyone have a question so far? Pretty simple. And again, easier, at least better than the row reduced echelon form. I can add matrix C, just like number. I can add matrix C as long as they have the same size. So the rule is they have to have the same size. And they're oh, I'm sorry, I'm sorry, not adding. Equality of matrix. I'm sorry about that. I got ahead of myself. Equality of matrix mean if the two matrices are equal, that means they have the same size and their corresponding entries are equal. Is the first one's equal? Are the two equal? Is the left-hand side equal to the right-hand side? Yes, right, yes. Even though they're written differently, but they are equal, right? The 2 here, the same thing is 1 plus 1. The 0 here is same thing as 4 minus 4. Or the 7 here, the same thing as 3 plus 4. And they have the same dimension, which is 2 by 3. They both 2 by 3. What about the second problem? Because different dimension, right? So it's 2 by 3 and this is 3 by 2. So nope. Yes. Solve for x, y, z, u. Any suggestion? Assume these two matrices are equal. Oh, okay. U3. Yeah, U3. Yeah, the easy one. Very good. Very good. On the exam, go for the easy one first. Right? If you stuck for more than 2 minutes, go on. Move on. Move on. Come back later. And then T, Z, Z. Okay, Z. Where is Z? Oh, Z is 2. Okay, so let me highlight Z in blue. So let's write the equation first. So 2Z equal 4 plus Z equal 2. And next one, yeah, 2x equal 3, right? 2x minus 1 equal 3, I'm sorry. Then x equal 2. Add 1 divided by 2. Last one, 7. Maybe I'll use black because I can't see the green. 7. Huh? 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 Oh. Trust me, it's kind of my head had to think multiple things at the same time, so sometimes I make mistake. Right? I gotta think how to talk to you, how to coordinate the colors, and what to say next. So multitask. But if I make mistake, let me know. Good, easy. Maybe it's a good problem on the exam. Easy points. Adding and subtracting. Now, like number, I can add matrix and subtract matrix as long as they're the same size. So for number, I say a plus b is don't write this down. Is equal b plus a. This is true. This is always true for any numbers. Yes, right? You just say 3 plus 2 is the same thing as 2 plus 3, right? So this is called commutative rule. Associative rule say I can sum up A and B and add to C. It's the same thing as sum up B and C and add to A. It's the same thing. So same with matrix. Same with matrix. Let me give you an example here. So 3 plus 2 is the same thing as, and then plus 1, the same thing as 3 plus sum of 2 and 1. Same thing. So in order to add two matrices, they have to have the same size. If they're not the same size, you stop. You don't add or subtract them, right? You say not possible. How do I add two matrices? Number to numbers, entry to entry. and the corresponding entries to each other. Same thing when you subtract them. Let me ask you something. You don't have to write this down. Is A minus B equal B minus A? No, right? It doesn't even work in number, right? If you take 3 minus 2, it's not the same thing as 2 minus 3. So it doesn't even work in number, let alone matrix. Why don't you guys do 1 and 2? That's easy. I'll walk around, see how you do. You got it? So 2 plus negative 3, right? And then here 3 plus 0, here 5 plus 8, and here 4 plus negative 4. 2 plus negative 3 is negative 1. 3 plus 0 is 3. And then 5 plus 8 is 13. And then 4 plus negative 4 is 0. Let me show you how to do this in calculator. I'll use a second example to do that. I forgot to use the in the morning class. Am I still sharing? Yes. It still froze. Oh my god, it froze from 2 days ago. Ah. I'm sorry, it froze. Maybe next time. Maybe next time. I'll show you next time. Okay, I gotta fix it. Maybe restart the iPad or something like that. All right, what you guys have for number 2? Yeah, subtraction, right? 0 minus 1 is negative 1. Negative 1 minus 3 is negative 4. 9 minus 4 is 5. 1 minus minus 1 is 2. So be careful of that. 3 minus 2 is 1. Minus 3 minus 0 is minus 3. 2 minus 4 is negative 2. 5 minus 8 is negative 3. 6 minus 11 is minus 5. Bless you. Not too bad, right? Not too bad. That's why I want to show you how to do a calculator. So that on the exam, at least you know you go back. But it froze. Maybe next time. All right. This one, and then we're done because that's why I stop in the morning. Yeah, we have 2 days to finish this short slide, so we have a lot of time. All right, law of addition. Like I said, matrix are commutative. Right, so this is commutative, double M. commutative law. And then the second one is called associative rule. Why don't you do number one? I'll do number two with you, but I want you to try number one. I want you to show that A plus B is the same thing as B plus A. Using the matrix, of course. Copy that down. In the meantime, I'm gonna restart my laptop. Maybe it'll help. All right, we're back. We're back. Are they the same? Yes. All right. This time I can show you with the calculator. A plus B. Let's do A plus 2 plus negative 1 is 1. 1 plus 2 is 3. 3 plus 3 6. Negative 2 plus 0. 1 plus 2. 0 plus 4. Thank you. Bonus share mark for you. Easy one. All right, so that's A plus B. I don't feel like doing B plus A. I don't know about you, but you can do it yourself. But maybe you can do it on the exam, on the calculator. So go to second matrix again. Go over edit. What is the dimension of the matrix? 3 by 2, right? So 3 by 2. I don't remember the entry, but let me pull it up. Two, 1, 3, -2, again, 1, 0. That's matrix A. I want you to quit. Make sure you press enter for the 0. Second mode to quit. Go back to matrix. Go over edit. Now, you just modified A. So do not modify A again. You want to save that A, right? Go down to B. So press the cursor down to B. That, and then now you're going to modify B. So press enter. It's the 3 by 2 again. And the matrix is -1, 2, 3, 0, 2, 4. Hit quit. Press second matrix again. Second matrix. A plus B. So names is matrix A, and then plus to second matrix, you go to get the matrix B. You go down there, matrix B, right there. And if you want to do B plus A, you go down to B first, and then plus the second matrix again, go to A. It's the same thing, right? It's the same thing. Show that A plus B plus C is the same thing A plus B plus C. All right, A plus B. We have A plus B. It's up there, part A, right? Let me copy down A plus B, which is 1, 3, 6, -2, 3, 4. And then maybe I'll use yellow for C. It's SC 1, 1, 2, 3, 0, -1. 1, 1, 2, 3, 0, -1. All right, add them together. What you got? One plus 1 is 2. 3 plus 1 is 4. 6 plus 2 is 8. -2 plus 3 is 1. 3 plus 0 is 3. 3. Thank you. Bonus check mark for you. And then now the right hand side. You want to sum up B and C first. You glue for B and C. All right, let's do by hand. You don't have to do matrix. -1 plus 1 is 0. 2 plus 1 is 3. 3 plus 2 is 5. 0 plus 3 is 3. 2 plus 0 is 2. 4 plus -1 is 3. I'll tell you what, you might make mistake on exam. Even though I say plus, for some reason, my brain thinking I'm multiplying. So it's very, when you do fast, like, oh, 3 plus 2 is 6. It's just your brain think differently as opposed to what your mouth say. So be careful on that part. And then maybe I'll do no A in black. 2, 1, 3, -2, 1, 0. Add them together. 2 plus 0, 2. 1 plus 3, 4. 3 plus 5, 8. -2 plus 3, 1. 1. 1. 1 plus 2 is 3. 0 plus 3 is 3. Are they equal? Yes. They are equal. We take a 5 minutes break. We'll stop here because that's where I stopped in the morning. Is there any last minute question for the quiz? Yes. Together. Okay, sure. Yes. Let's do. Do you have one for me, or you want me to make one up? Right here. I got it right here. Let me see. Let me look up one. Yes. Oh, yeah, one. Okay, okay, yeah. Anything but not infinitely many solutions. Because your quiz gonna be have one solution.
It's from the homework.
You have solution?
I don't know because I didn't solve it because I didn't know how to
Did
do
you
it
do
on
on
the
the
homework.
calculator?
Actually no, I haven't.
Yeah, let me try and see. Look in the calculator, see.
Okay.
Second matrix. Because I don't want to do the one that is not similar to the. Yeah. Oh, not really. Second.
I don't know. It's on the homework and I didn't know how to do it. So.
2, -1, -1, 3, 3, 2, 1, 8, 1, 2, 2, 4. Yeah, you have a solution.
It does?
Yeah.
Okay. Wait, this one.
No, that's good. I'll do it together in the class. Oh, -y. Right?
Oh yeah, sorry.
No, that's okay. -y.
Wait, that was how it was showing up in the homework though.
Huh?
That was how it was showing up in the homework though. It was giving us X's. Like there was no Y's.
I mean x1, y2, x1, x2. Yeah, it's the same thing. Yeah.
Oh, okay. Why does it show up in that format?
Because at some point you're gonna run out of letters.
Oh.
Yeah.
Oh yeah, yeah.
Yeah.
So
Yeah. Equal 3. All right, let's do this one. Can you see? I did my iPad in black, so it's easier for my eye, but can you guys see fine? All right, so convert this into matrix form. 2, -1, -1, and then the equal sign is represent use a line. 3, 2, 1, 8, 1, 2, 2, 4. What's my first step? Beside right now the matrix. Huh? Yeah, flip, right? You don't have to, but recommend you should. Right? So that you don't run into a fraction. So R3 becomes R1, R1s become R3. And please do write out those steps, because if you do something wrong, the grader can or we can retrace what you do back, right? If your answer is wrong, and I cannot give you partial credit because I don't know what you're doing. 1, 2, 2. When you flip, everything move, right? You want the 1 to be up here, then the whole row go as well. 2, -1, -1, 3, and then rewrite the second row. 3, 2, 1, 8. I identify your diagonal, which is that one. Everything below diagonal has to be 0, starting with that one, right? So what I do? Yeah. So the for D2, we're gonna use the first row. Right? So -3 times R1, add 2 R2. That's give me new R2. The arrow imply which row to change. So let me rewrite the first row. 1, 2, 2, and then 4. -3 times 1 is -3 plus 3 is 0. -3 times 2 is -6 plus 2 is -4. -3 times 2 is -6 plus 1 is -5. -3 times 4 is -12 plus 8 is -4. Let's eliminate 2 as well, because I don't want to rewrite another matrix. What do I do if I want to eliminate 2? Add R3, then R3 change, right? So -2 times 1, -2 plus 2, 0. Negative 2 times 2 is negative 4 plus negative 1 is negative 5. Negative 2 times 2 is negative 4 plus negative 1 is negative 5 again. Negative 2 times 4 is negative 6. I'm sorry. That's what I'm talking about, the arithmetic. 8 plus 3, negative 8 plus 3 is negative 5. And then what do I do next? Eliminate negative 5, right? What row do I use? Yeah, second row. So what do I multiply the second row by? Close. Negative 5 over 4, right? Negative 5 over 4. So negative 5 over 4 R2, and then add to R3. Give me new R3. Let's rewrite the first two rows. First thing first. We'll think about that later. All right, so that's gonna be 0. We know that, right? What's negative 5 over 4 times negative? Oh yeah, negative 5 over 4 times negative 5 add to negative 5. Use your calculator. Make sure you use parentheses in everything. So negative 5 divided by 4 times 5. No, times negative 5. Jeez. Huh? Yeah, minus 5. What is wrong? Why I have syntax error or something? I did something. Maybe she fixes what I did. All right, 5 over 4. Thank you. 5 over 4. And then the last one. Right here. Let me show you, because on the exam, on the quiz might be a problem. So negative 5 divided by 4 times negative 5 and add to negative 5, which is subtract 5. It's 1.25. And you want to change to fraction, you go to math and double click. All right. 5 over 4. 5 over 4. What about the second one? Or the last one? Negative 5 over 4 times negative 5 over 4 times negative 4 add to negative 5. What you get? It's the same thing, right? 5 over 4. Did I do something wrong? No. No, 0. All right, the last one 0. The 4 cancel, and then the 5 and negative 5, so 0. All right, substitute. Someone read me the equation.
X plus 5 plus 2z equals 4. Negative 4y plus negative 5z equals negative 4.
Mm-hmm.
Then 5 fourths z.
Good. Then z equal 0. 5 over 4 times something equals 0. That's all right. You plug in 0 for z. Negative 4y equal 1. And then plug it back here. X plus 2 times 1 plus 2 times 0 equal 4. X equal 2. Very good. So 2, 1, 0. All right, let's do the, I want you to spread out as much as possible, please. Just skip a C, that's all. Skip a C. Yes. Oh, you don't have one? I'm sorry. Oh, no. I didn't mean to. That's okay. Thanks. And please show step, okay? If it's something wrong, I can give you partial credit. No, Gauss Jordan. I mean Matrix. Use Matrix, yeah. Just like I did earlier.
Okay.